Hi everyone, I'm Megan Van Meter, and I have been brought here to present to you Creativity as an Agent of Neural Integration, the Expressive Therapies Continuum, one of my pet subjects in the whole wide world. Currently, I'm a visiting assistant professor in the art therapy program at the Heron School of Art and Design at Indiana University, Purdue University, Indianapolis. We call it IUPUI, just to be brief about things. One of your faculty members contacted me after seeing my presentation at the 49th Annual Conference at the American Art Therapy Association in November 2018 and asked if I would put together a presentation for you based on that presentation. So this is for you at Southwestern College in the Graduate Art Therapy program. I'm recording this in October of 2019. And something you should know about me is I went to the University of Louisville, which is one of the oldest, arguably the oldest graduate art therapy program in the country. And I learned from Marcia Rosal, Sandra Kagan, who was Sandra Graves to me, now she is Sandra Graves Alcorn, and Via Lucebrink. And it was Via Lucebrink and Sandra, who was Kagan way back in the day, they conceptualized the expressive therapies continuum and wove it into just about all of the coursework at the University of Louisville. So my preparation for practicing as an art therapist is really grounded in the ETC. That's what I'm going to present to you. Right now you're looking at 6 paintings. All have been done in oils. That's going to be significant. Not that they're oils per se, but that they were all done using the same art material. I did these in college. They were for various assignments in different classes. So to look at any one of them, you don't necessarily get a sense of my style. You can see that I was completing assignments. This is the last time that I made artwork in the absence of knowledge about the expressive therapies continuum. So I look back to my college work and try to figure out, wow, what kind of mental activity was really being stimulated in the different assignments I did for college. As you can see, they're all different, and you're going to see these again throughout the presentation. My hope is that you will also look to your own artwork after this and begin to kind of get a sense of, what ETC components you might be favoring, which ones you might not be favoring so much, and the ways in which your biases about the ETC components may have accidentally worked their way into your clinical practice with others. So here you have the schematic of the ETC. I dressed it up with the functions of each component and the creative level up at the top. But basically this is what Kagan and Lucebrink put together in 1978 and rolled out to the art therapy community, which at that time did not understand any of this. Art therapy was not being practiced in this way at all. So it didn't gain much traction until about 2009 when Lisa Hines put out her book, The Expressive Therapies Continuum. You may be reading it. As of this date, she has just put out her second edition, so gaining a lot of traction in the world of art therapy, but it's been around for a while. So this is really a systems model. Changes in input is going to lead to changes in output. Just to get into the schematic a little bit, you'll see this slide again as well, but we've got at the bottom level is kinesthetic and sensory. Kinesthetic is the manifestation of muscular constructs such as action and effort, and it's counterbalanced with sensory, which is the reception of somatic stimulation from inner and outer sources. So an optimally functioning person can make sense of information in both directions. Moving developmentally up the ladder, we have got the emotional level. That is perceptual information processing, which is about the calibration of internal rhythm and environmental structure. And affective, on the other side, which is the materialization of mood conditions and motivational drives. That's important. Affect is not just about mood, it's also motivation. That is also part of the limbic system in the brain. Then up at the top level, we have the intellectual level, which is split between cognitive information processing. That's going to be the construction of logical concepts through analysis and synthesis. And over on the right, we have symbolic information processing, which is the identification of subjective meaning and personal significance. So if you look on the left side of the schematic, all of that is externally oriented, muscular efforts that direct energy outward. Perception is really about how we attend to the external world and integrate that to help calibrate what's happening within us. This is where engagement with external reality is really important so we don't get so sucked into ourselves. And then the cognitive component is also going to be generalizing based on logical applications. This is all external. The right-hand side of the schematic is more internal. Sensory, those are going to be internal, not feelings. We're going to attribute that to affect. But this is going to be internal messages such as, I need to use the bathroom, I'm hungry, I'm tired, I hurt. Affect is going to be motivation, either towards something or away from something, such as procrastinating when you have homework. Most students know that one, as well as our mood conditions. And then symbolic is our personal attribution of meaning, what's significant to us, what is symbolic in our own world. So we've got the external, internal world split, and over on the left side, that's going to be more about explicit information. What's on the right side of the schematic is more about implicit. And up at the top, combining all of these things together is the creative level, which is the generation of resilient responses to stressors and situational demands. This is important for you to understand. Someone sitting down and cranking out a painting that looks like a lot of the other paintings they've produced, perhaps they're going to sell them at an art festival or something. That's not the kind of creativity we're talking about here. This is about novelty, what the brain has to go through when it's faced with a situation it's never met before. If we've got a lot of internal resources based on our ability to process information on these 6 components, we have a pretty good chance of demonstrating the ability to get through that new situation. But our clients come to us perhaps because they don't have the neural pathways to help get them through. And it's our job then to figure out where on the ETC do they function well, where are they stuck or blocked or perhaps over-functioning, and to create treatment that starts them on the ETC component where they're comfortable and move them throughout the schematic in a very sequential manner. It's kind of like checkers. You know, you can't just go hopping all over the board. Same here. You don't just go jumping from cognitive to sensory just because you feel like it. But we want to guide people thoughtfully through the schematic to eventually land them back where they started, only this time they'll have a lot more skills with them. And that is really what the creative level is about. Now, each of these 3 levels rises up through a process called emergent functioning. Dan Siegel, if you know him, he talks a lot about emergent functioning. The ETC got there first. But anyhow, emergent functioning is what leads from one level of the ETC upward to the other. To demonstrate quickly, I'll just talk about a drumming circle. Over on the left-hand side of this schematic, we've got kinesthetic is going to be when you show up to a drumming circle, it's noisy. People are just banging away to their own rhythms. But then something happens. Without any orchestration, people shift and they start matching each other's rhythm. They've automatically moved up to perceptual information processing, really internalizing external forces, external rhythm. And from there, people start riffing off that basic group rhythm and it becomes increasingly complex. People have reached the cognitive component, all without any orchestration. On the right-hand side, let me show you what emergent functioning looks like in terms of transitional objects. So sensory, at some point, the young child will get a hold of something usually soft that has a texture or a scent that is reminiscent of a primary caregiver. That object starts bringing them comfort because it's got the sensory cues of the comforting person. So we've got sensory taken care of, we've got affect. Eventually, that piece of material or whatever it is, the stuffed animal, the blanket, takes on symbolic significance. It becomes the comforter. It becomes the non-animated embodiment of that primary caregiver. All that happens without orchestration too. So emergent functioning is a pretty powerful force within the ETC and in other elements of life. I threw this slide in here just not so much for you, but you may need to educate other people about this as you go out and start preaching the gospel of art therapy, that creativity is not just about making art. It's really about an integrative focus, introducing people to what's new so they can reach their potential at home, at school, at work, and in life. This is a slide that just begins to illustrate the importance of resilience. We've got the nice healthy brain inside the light bulb. It's shining. This is resilience. If you can connect information related to your physical, emotional, and intellectual experiences, that is going to lead you toward resilience. Again, think of the creative level of the ETC. So this is what is going to help us tackle new challenges and demonstrate resilience in the face of those new challenges. Uh-oh, something went wrong. So when we have broken or disintegrated connections in terms of physical, emotional, and intellectual information processing, there are going to be troubles. It's important to pay attention to this in terms of the physical, because physical intervention has been so left out of mental health intervention across the decades. That's really where art therapy can come in to shine, but we have to be deliberate about it. We can't really just get by with talking head stuff and expect that we've reached the physical. When we ignore the physical, we are ignoring the foundation of integrated functioning. I'll let you take a moment to read this. So now I'm going to ask you to stop thinking of the brain as just something that's in your head. It occupies your whole body. It's your nervous system. That is where we're connecting physical with emotional, with intellectual. We need that whole body in art therapy intervention and other kinds of intervention, frankly, in order to help us get over the hurdles of life. The next few slides are going to introduce you to a few scientists who are doing work that seem to support the conceptual framework of the expressive therapies continuum. But please understand, probably none of these people have heard of the ETC. So they're not ETC experts. They're just doing work that I think is very relevant. Via Lucebrink herself has referred to Joachim Fuster. He detected that sensory information is processed in a hierarchy consisting of 3 levels. So we've got a parallel to the ETC right there. First of all, we have the primary sensory cortex. So when you are touching something, say, primary sensory cortex is picking up the basics of what you're touching. Then it moves on, the information travels on to the unimodal association cortex, where it starts processing through the related attributes. Nothing is hot until you have something to compare it to. Nothing is rough until you have something to compare it to. So now we're kind of working through this comparative system within our brains. It's not conscious whatsoever. It's picking up more detail about the related attributes of touch, since we're using touch in this example. Then it travels onward to the multimodal association cortex. That's integrating across multiple sensory modalities. So think about trauma being triggered by touch, a certain fabric, something along those lines. It's because of that multimodal association cortex that now we've linked touch to a painful event in our lives, and suddenly we have one of trauma's ghosts haunting us, whereas prior to touching whatever it was, we were just fine. Now we have Bruce Perry. Some of you have heard of him. He really specializes working with traumatized children, and he studies their brains in his neurosequential model of therapeutics. He gets a very detailed history of when the abuse happened, how severe it was, what kind it was, and since he's a physician, he's able to detect, okay, when that happened, this child would have been really working on brain development in this certain part, this certain part, this certain part. So he's figuring out through histories, detailed histories, what parts of the brain have been most affected by the abuse or neglect. And that's where he decides interventions most need to take place. It's not just one size fits all, it's specific child to child. Very similar to the ETC. It's a client by client thing. It's not like a car wash where you just run people through it. It's also a bottom-up approach. The lowest areas of the brain are treated first because that's your foundational stuff. He doesn't worry about the prefrontal cortex until everything else is good and well, and also the prefrontal cortex doesn't really start maturing until much later anyhow. So this kind of strikes me as being very similar to the ETC in that it is not one size fits all. It's a model of understanding what's happening inside the brain of the individual and how we can construct treatment to most fit that client's needs. Stephen Porges and his polyvagal theory have really taken a lot of the therapy world by storm. He discovered that the vagus nerve is bidirectional. You actually have two. It's not just one vagus nerve. There's actually two. Why it is referred to as a singular, I can't explain. But anyhow, just know it's bidirectional. It runs top down, bottom up. From your brainstem to your colon, it is the longest nerve in your autonomic nervous system. Helps prepare you for things like flight or fight. It's also important in integrating overall nervous system functioning. For example, bottom up is going to be that gut feeling that you may get that moves you towards something, away from something, but very rapidly. It's just a gut feeling. You cannot describe what it's really about. You just get that gut feeling and you act upon it, sometimes, oftentimes without much conscious thought, because it's really influencing your viscera as well as your facial muscles and vocal prosody. Vocal prosody, think of sing-songiness versus someone who talks kind of flat. So top-down example would be one day in high school, I was in a bad mood, as are many high schoolers, and I decided I was going to smile anyhow. I don't know why I decided that, but I did. I smiled, and after about 15 or 20 minutes of smiling, my mood was totally different. My body was more relaxed. Wow. So top-down is going to take a little more effort to affect the viscera, more conscious effort to affect the viscera, whereas when the viscera are affecting the facial muscles and the vocal prosody, that's pretty automatic. It's been suspected that people who have poor emotional or limbic regulation also have poor vagal functioning. This is really important. Integration, bottom up and top down, just like in the ETC, is pretty crucial to optimal functioning. Now we have Alan Shore, who is not related to Annette Shore. She is an art therapist, and she spells her last name without the C in it. Anyhow, he is really about the neurobiology of attachment. And insecure attachment, he argues, is an adaptive response to relational trauma early on in life. And this relational trauma is going to connect with disintegration of cognitive, emotional, and behavioral functioning. And he argues that it is very important to vertically integrate from the lower areas of the brain upward. All of this is important for optimal functioning, very much like the ETC, integrating vertically. We also are, in the ETC, are interested in integrating horizontally as well, but integration is important. He also has said that insight and awareness are not enough. It is not enough to make the unconscious conscious. We have to change what's in the unconscious in order to really positively affect the person. And now we have Dan Siegel. I talked about him a little before with emergent functioning. Mind, sight, and interpersonal neurobiology are his big things. And one of his quotes is, see inside the see inside. That's self and also others. If you can't see inside yourself to see the see inside, you won't be able to see the see inside someone else as well. He really toggles between chaos versus rigidity as kind of an indicator of a disintegrated brain. Comparing this to the ETC, too much chaos is going to be overfunctioning on the affective component, while too much rigidity is going to be associated with overfunctioning on the perceptual component. But he's also about integrating those cortical and subcortical areas of the brain. We need to connect those via the process of emergent functioning and directed treatment. And being able to recognize and respond to yourself and to other people is a byproduct of an integrated brain. Now on to Bessel van der Kolk. The Body Keeps the Score is his big book a lot of therapists have been reading. Again, underscoring the importance of the physical. Sense of physical mastery is key to recovery in his eyes. He is not a fan of talk therapy. He is a fan of using the body in therapy deliberately, not just accidentally. So traumas, disruptions, disconnect essentially nervous system functioning, limbic system functioning, other brain regions. And when you see someone who's having kind of a response that doesn't really match the situation, that's because something is disintegrated about their information processing in the brain. So he is all about body-based interventions, like I said. If someone can take a pair of scissors and learn how to use them effectively, that gives them physical mastery. So we as art therapists, I think, have some kind of a obligation to help our clients with the physical mastery of the materials that they're working with. Here's the schematic again over on the left. This is about the creative level. That's what this slide is for. And again, I want to reiterate, it's not just about making or producing. It's really using the whole brain when done correctly. It's integrative from the left side to the right side and from the top to the bottom. So someone who's living close to the creative center, that creative pole, they're going to have easy access to all of the other components because they're pretty balanced. It's when people are living way off to the edges of the schematic that you find we've got some issues that we need to address in treatment. They're overfunctioning somewhere, they're underfunctioning somewhere, having difficulty accessing the creative level, which is all about integration. So down below here, we've got some bullet points that reflect treatment goals associated with the creative level. They're taken from Wallace, somewhere in the 1920s, I believe. He posited a model of creativity, or a theory, 4 stages: preparation, incubation, illumination, and verification. Preparation is really about just, wow, being open. We have clients we need to help open up to other ideas and exploration. Incubation is really about, we don't know. And our clients come to us kind of nervous and anxious because they don't know. Helping them understand that's part of the creative process may be a healthy way to reframe that experience of not knowing. Then we have illumination. Everyone loves that. That's eureka. I've discovered the idea. My problem is solved. Woohoo! But actually there's one more step, which is verification, where we're evaluating how well did my solution work. Sometimes we have to go back to the drawing board and deal with all the feelings that go with that. We're often thrown back into one of the earlier stages. Preparation, incubation, or illumination, perhaps. So this is about accepting what has come to pass and realizing when it's time to wrap it up and move on. And a lot of our clients need help with that. We can assist. So here we've got a slide about the neuroscience of creativity. Roughly 3 large-scale brain networks. The executive network is kind of what you're expecting. Very focused, very attention, one problem at a time, evaluating all along the way. Then we have its twin opposite, the imagination network. This is also called the default network because It's what state you're in when you're not busy focusing your attention through the executive network. We relax into the imagination network or the default network. There's nothing bad about that. This is open-ended. This is where possibilities arise. This is where problem solving can really take shape. It's also important in social thinking, and it explores options. What if I hadn't done this? Should I do that? This is really relevant to automaticity, like things getting done immediately without having to think about things. Thinking about things is going to be more the executive network. Salience network is balancing the needs of the inner and the outer worlds and trying to figure out what really needs to happen here. So are we going to use the executive network to solve this problem, or are we going to enlist the help of the imagination network to get the problem done? And studies have found that very, very creative people are able to keep both the executive and the imagination networks going at the same time to solve a problem. This slide gives you a little taste of what the executive network might look like and the imagination network. They both start toward the back of the brain in the occipital lobe that processes visual information. Hint, hint, art therapists. The dorsal visual stream is associated more with the executive network. It's kind of the where is it? Where is this information? Rising up across the top of the brain toward the prefrontal cortex, while the imagination network takes a southern route. That's associated with the ventral visual stream, where you're identifying what something is. So this takes a swoop down toward the temporal lobes there, resting near your ears, kind of like the sides of a football helmet. And it's through these deeper processes that we're interacting with the limbic system and infusing imagination and default thinking with our feelings and our emotional state. So you are looking at the salience network. You're watching the brain spin. Salience network is most strongly associated with the anterior cingulate cortex. If you know what the corpus callosum is, that's the giant cable of nerves that is known for connecting the right and left hemispheres of the brain. There are other connectors. This is just the big one, the big kahuna. Riding on top of that is the anterior cingulate cortex. It also is shaped like a C that tipped over. And you'll see it spinning around now. Right there, it's red, you see. Anterior is the front. That bumps up against the prefrontal cortex, although the cingulate cortex itself is referred to as being part of the limbic system. So there's some connection here between feeling and thinking. Over on the right, we've got our anterior insula coming into view. There it is in red. Now it's disappearing. There it is in red again. Now it's disappearing. That is really something that's associated with a sense of self. Not just psychological, but physical. It's got some implications in terms of perhaps schizophrenia. When you've got someone wearing lots of layers of clothes in the middle of July, they're trying to define a physical sense of self. It's also impacted in eating disorders, where that physical sense of self and the psychological sense of self might not match. So there's really this internal-external thing going on with the anterior insula. And between these two things, these are most strongly responsible for helping us determine in any given situation, in any given moment, what do I most need to do in this situation? That is the function of the salience network. Okay, we're back to the schematic. I throw the schematic in here every now and then. After brain slides, I find that people are a little lost. So ground yourself with the schematic. And now we're going to move on. Okay, time for more brain. Fasten your seatbelts. Okay, here we are, the kinesthetic component of the ETC. Remember, manifestation of muscular constructs such as action and effort. And the painting here is really about movement. It's really not about anything else. And what you don't know because you didn't see me make this is that this painting and just about all the rest, I achieved this look by grinding the paint into the canvas, which after a few decades presents some different kind of problems on the back side of the canvas, but that's a different story. Anyhow, This has been ground in. Lots of energy and action and muscle went into making this, as well as with the light strokes that I used with the brush. So artwork that tends to portray movement and record motor activity is definitely going to be housed under the kinesthetic component. And you'll see 4 bullet points here that really align with treatment goals that can be used when trying to heighten a client's awareness of their own kinesthetic information processing. So I'll let you read those for a few seconds. VIA in 2010, in a 2010 article, did take a stab at trying to determine what brain structures may be most closely implicated in terms of the components of the ETC. So there's no science to prove this yet. This is just kind of a parallel. So the kinesthetic component appears to implicate the basal ganglia and the primary motor cortex. The basal ganglia is really implicated in distinguishing between voluntary and involuntary motor movement. If you know someone with Parkinson's, they've got basal ganglia impairment, and that's something that's housed at the very, very center of the brain. The primary motor cortex is going to be on the outside of the brain. We're going to be taking a look at that in a moment. Here we have sensory information processing, the reception of somatic stimulation from our inner and outer sources. Now the painting that went with this, I couldn't grind the paint into it because, as you see, it was kind of bundled up, and I textured it this way. I put plaster in the gesso and molded it to a form. This is a close-up. So this is more about the dribbling and the dripping and the watching the colors bleed and blend into each other. All of that is going to be very sensory, and you can see by the image here there's a lot of texture going on as well. Sensory information processing. A lot of our clients come to us being very sensorially out of touch with themselves. They eat when the clock tells them to, not when they get a sense inside that they're hungry. They've sort of farmed out their sensory responsibilities to whatever the iWatch is telling them. But sensory information processing is huge and necessary for successful living. I'll let you take a look at the bullet points that address treatment goals concerning sensory information processing. According to Lucebrink, sensory information processing appears to implicate the primary somatosensory cortex. So we're going to be taking a look at that. That is going to be on the outside of the brain. The next slide is going to be kinesthetic and sensory information processing as seen through the brain. So here we have it, kinesthetic and sensory as proposed by via Lucebrink. Over on the left we have the basal ganglia, and I'm going to show you. It's really this kind of stuff we're talking about at the center. It's sort of a swirly. It's a collection of all these different structures. You can see their names in the slide too. And over on the right-hand side, I've drawn a red circle around the primary motor cortex. You can see it in red. Right behind that is the primary somatosensory cortex. Now, the primary motor cortex is part of the frontal lobe of the brain. So it's intriguing to me how long it has taken science to figure out that if you give students things like standing desks or desks with pedals, that they're able to increase intellectual functioning while in school. You know, from the perspective of a neuron, growing from the motor cortex to the prefrontal cortex is not that great a leap. The primary somatosensory cortex is actually not in the frontal lobe. It is actually in the parietal lobe, which is more associated with sensory information processing. Now we're moving on to perceptual information processing, the calibration of internal rhythm and environmental structure. So we're on the emotional level now, folks. Kinesthetic information processing rises to perceptual information processing via emergent functioning. And the painting, as you can see, It's colorful, but there's a whole lot of emphasis on form. Form and structure is going to be kind of a hallmark of the artwork done by someone whose primary mode of information processing may be perceptual. Also, introducing form through therapeutic activities is going to be part of a treatment plan for someone who has difficulty in this area. Take a look at the bulleted points in the column on the right. That's again going to be treatment goals related to perceptual information processing. Lucebrink figured that perceptual information processing has a lot to do with the ventral visual stream. And you'll be seeing that in a moment. You've actually already seen it before, but we'll revisit it in a moment. But first, we're going to look at a slide that is about affective information processing. Look at how different the image is here. This is affective information processing. Form has kind of started to loosen up a lot. So we may have open forms, just a dynamism. Very different from kind of playing with design basics, perhaps. A lot of people mistakenly think art therapy is all about emotional expression, which targets the affective component. Not so much. Art therapy can be about kinesthetic, sensory, perceptual, cognitive, and symbolic information processing, not just affective. But this is where the materialization of mood conditions and motivational drives is really the primary focus of treatment. Take a look at the bullet points that lend themselves to treatment goals. I'll give you a few secs. Lucebrink believes that affective information processing is really about the amygdala's influence upon the ventral visual stream. So with the amygdala being the am I safe button and am I intrigued button perhaps, that's what this is about. Something that's more neutral isn't going to really trigger the amygdala. So this is something that's going to excite the amygdala. Positively, negatively doesn't matter. This is just something that's going to excite the amygdala. Okay, here we've got it. The brain, according to Lucebrink's interpretation of perceptual and affective functioning. If you go over to the image that's on the left, we have got a view of the brain from the front, but it's the inside of the brain, and it's been split open. So the amygdala has been circled in red. That's where it's housed. It's at the tail end of that swirly thing you saw in the basal ganglia image. Now down in the very lower left, that's just another picture that shows you the amygdala down at the end, but that swirly thing is part of the basal ganglia. Please keep that in mind. Over to the right. It's a slide you've seen before, but now we're going to focus on the ventral visual stream, starting in the occipital lobe and running south, not north. And it's going to catch up with the limbic system and intermingle with the amygdala and either draw us towards something or push us away from something. If the affective system is not really involved, we're going to feel neutrally about something and not get emotionally involved at all. Now we have reached the intellectual level. It's not the superior level. Really, when you stop and think about it, the most important level would be the physical level. Everything else is built on that. But here we are at the cognitive component, the construction of logical concepts through analysis and synthesis. If you're familiar with school, which you probably are because you're a student, you know there's a lot of focus on cognitive information processing. Take a look at the laundry list of treatment goals associated with cognitive information processing. They're on the right-hand side. So every still life you see, you know, was constructed to be somewhat logical. Yes, it's an interpretation through the eyes of the artist, but it's still using logical cues. There's nothing particularly emotionally expressive going on. You are building upon the basic patterns that you may have seen in the perceptual information processing component. We start to get a little messy here because we're dealing with slightly more brain territory, I guess you could say. But Lucebrink thinks that the cognitive component appears to implicate the prefrontal cortex, particularly the dorsolateral prefrontal cortex. That's going to be the top side. And possibly the anterior cingulate cortex, which you saw in one of those rotating brains associated with the salience network. We're going to get to that in a minute. We're going to take a look at symbolic next. Okay, here we are, symbolic. There may be some mystery there. This bird has an environment, but we don't know what it is. Tail feathers flying underneath it is very unusual. Most tail feathers do not fly directly underneath as if there's a U-turn being made. And this bird has no facial features. Lots of mystery here. Symbolic information processing may be more commonly associated with finding meaning. The finding of meaning. It's not just a, this means that and that means this kind of tit-for-tat arrangement that you may find in a symbol dictionary, for example. This is about the identification of subjective meaning and personal significance. Take a look at the bullet points that go with that. Those are treatment goals for symbolic information processing. According to Lucebrink, the symbolic component appears to implicate the orbital frontal cortex, so that's going to be out in front, right above your eyes, and possibly the posterior cingulate cortex. You've seen the anterior cingulate cortex. Posterior is going to be the back. So we're going to take a look at that in the next slide. So there is a whole lot of brain going on here. Sorry, I used open access slides, so I did not have to pay royalties. And this is what I could find for combining cognitive and symbolic. If you look at the brain over on the upper right, that brain is facing off to your right. The dorsolateral has been identified. That's going to be a little more associated with cognitive. The orbital frontal is there in the periwinkle color. That's going to be associated more with symbolic information processing. And there we have down below those two brains, the one on the left is an exterior. It's facing to the left. The dorsolateral prefrontal cortex has been identified. The orbital frontal cortex, or OFC, that's also been identified. And then we look at the brain cut in half over on the right to show you the inside. ACC is anterior cingulate cortex. PCC is posterior cingulate cortex. Anterior cingulate cortex, remember, probably associated with cognitive information processing. The posterior cingulate cortex, likely associated with symbolic information processing. And this right here, that thing that tipped over, see, that's your corpus callosum. So you can see how the cingulate cortex just lies on top of that. This is the creative level. You have seen the bullet points again on an earlier slide. I'll let you take a few minutes to look at those as treatment goals. This is the generation of resilient responses to stressors and situational demands. And if you look off to the left, you'll see all 6 of those paintings stacked up again in thumbnails. On the bottom, we've got kinesthetic sensory. In the middle, we've got perceptual affective. At the top, we've got cognitive symbolic. And the creative level, remember, rises vertically to connect all of them. I'm going to attempt to draw a straight line. It's not going really well. But at any rate, you get it. That's the creative level, what I just drew for you there. To pull them all together so that clients have easy access to using whatever kind of information processing strategy they need for whatever challenge they're dealing with, instead of using something that's habitual but not working. According to Lucibrink, horizontal transitions that cross from, say, perceptual to affective or from symbolic to cognitive, they appear to implicate the thalamus and the amygdala. The thalamus is a giant relay station for sensory information up to the cortical layer of the brain. That's the squiggly stuff on the outside, the cortex. And the amygdala has a function in the limbic system that's kind of the am I safe button. It's emotional arousal or not. We're going to take a look at that in just a sec. Okay, so we've got the thalamus. You've seen this again. The brain image on the left, you've seen this. The thalamus and the amygdala have been highlighted for you, part of the basal ganglia. And on the slide up on the upper left, the upper right, that is the thalamus. And the slide on the lower right is an amygdala that's been highlighted, just so you can see where we are in the brain. Okay, we're back to the schematic. We're out of brain for a moment. We'll go back to it, but just breathe, look at the schematic. Okay, we're going to deviate from brain for a little bit to talk about media dimension variables. It's really the subject of its own lecture, but I'm going to give you a little taste of it. Kagan, back in her master's thesis, 1969, she cooked this up. She is a genius. We could have been doing quantitative art therapy research with the media dimension variables had people really taken all this to heart. But she was able to determine that all art therapy interventions can be broken up among media dimension variables. Task complexity, there's low complexity, which is 1 or 2 sequential steps for successful completion. There's high complexity, which is 3 or more steps. This is not about get up, take 3 steps to your left, pick up the pencil. It's not all of that. It's what you're putting in someone's working memory. Paint a picture of your mother. That's 1 step. It involves many sub-steps, but if what you're telling them is paint a picture of your mother, that's going to be 1 step. Task structure is another variable. Is it an unstructured task? Meaning, paint a picture of your mother. Probably if you were doing that in a group, you'd get a bunch of pictures of mothers, but lots of outcomes in terms of how they get produced. Structured is going to be a minimal range of possible outcomes. Let's everybody draw a hand turkey, or let's make a snow person. That tends to be very structured. Yeah, you can individualize it somewhat, but in the end, everyone in the group is going to have something that looks like everyone else's product. Then there's media properties. You might already have thought about those. Fluid are materials that are going to have less inherent organization, perhaps watercolors, perhaps oil pastels. Resistive is going to have more inherent organization. Think working with wood, think pencils. And MDV are stated in terms of whatever horizontal ETC level an intervention is addressing. So look down below. You see all those possible MDV combinations? We could be doing research with this. Here we have got MDV for adult coloring books. Let's try to go through this together. What do you think the task complexity is for adult coloring books? What are you really asking them to do? What are you putting in working memory? Here's what I think. Low complexity. You're not asking them to do a whole lot. Take the materials and color in the open spaces here. Task structure. What would you say? Unstructured or structured? If you guessed structured, you're on the right track. People get to choose their own colors. Maybe they're only going to use warm, or maybe they're going to use a cool palette, but pretty much everyone's going to wind up with the same looking image, just with different colors in it. Media properties, fluid or resistive? Resistive. Usually what people are using in an adult coloring book would be very fine tip markers or coloring pencils. Now, do you know what level of the ETC adult coloring books target? Kinesthetic sensory, is this physical? Perceptual affective, is it emotional? Or cognitive symbolic, is it intellectual? Yep, LCSR on the perceptual affective level. This is really about emotional containment. So before you diss adult coloring books as a treatment strategy, please know there are people who do need this for assistance with emotional containment. So here we have the schematic again, and we have thrown in there high task complexity, structured tasks, and resistive media, all likely to elicit thought-based responses. And over here, low task complexity, unstructured tasks, and fluid media are more likely to elicit feeling-based responses. Now, none of this is set in stone because it really depends on the other things you throw at them. Are they working with clay hands-on, or are they using tools to distance themselves from the clay, for example? Okay, we're going to do some brain again, folks. Buckle up. Again, about media properties, resistive, fluid, there's really a continuum, but it's important for you as art therapists to really recognize that they influence psychobiological functioning through somatosensory processing, fingertips, hands, and also visual perception, our eyes. The eyes have it. Now I'm going to take you on a quick tour of somatosensory processing. This will not be detailed. There will not be a test. But anyhow, over on the left, you can see the innervation of the hands, the fingers, the arm. Innervation just means the distribution of nerves. Over on the left, you'll see that innervated hand and arm. On the right, I'm going to show you where it's connected. It connects. This up here is really here, the brachial plexus. From the brachial plexus, nerves go upward. I'll draw an arrow here. To the brainstem. That's what's on the right-hand side, a big, huge brainstem. And you see we've got the thalamus right here. Circle that. And we've got thalamocortical fibers. They connect the thalamus to the outer cortex of the brain. Okay, so here we have the familiar image on the left. On the right, this empty part's been filled in. Over here, look what we have, an optic nerve. How about that? That may have something to do with what we're going to see later. Okay, here is the fully fleshed out brainstem with that optic nerve again right here. We've got some other important structures like the hippocampus, which is implicated in memory. See these olives? We're not going to talk about the function of the olives, but you can tell that those are the knees of the brainstem basically. Knees face forward. So that tells you what direction this brainstem is facing. Right here are going to be the olives. For this brainstem, I'm just showing you brainstem from the side, and here's the brainstem from the front. So the olives are going to be, I shouldn't have used red, but you kind of get the general idea. The olives are going to be there. Here's the swirly stuff inside, woo! And it's hiding back here too. Okay, so there we've got the brainstem side and front views over on the left, and back to another familiar image right here. So this image is the same thing as this one over here. This is, again, things have been splayed out here in the middle so you can kind of see what they look like because the thalamus is hiding inside that basal ganglia, which is, implicated right here. The corpus striatum is essentially part of it. Okay, and we go again from this familiar image to the two images on the left. I'm sorry, the right. I'm getting mixed up today. But anyhow, you see the thalamus and you see the amygdala. All of this has to do with somatosensory processing when you hand someone art materials prescriptively. Now we're going into visual perception, so the eyes have it. This thing below you is essentially a brain and an optical system. The back of the brain has been cut off and laid on a table, so the eyeballs are staring straight up at the ceiling. I personally think this would make a fabulous Halloween mask. Most people don't find that to be funny, and I don't know why. But anyhow, that's what we're looking at. So from the eyes, we come down here, kind of go around this funky thing, then it wraps around. This eye is doing the same thing coming from another direction. This wrapping around. But there's material hidden by these. This is the temporal lobe. This is another temporal lobe. It's hiding information from us. Okay, there's the familiar image, the Halloween mask. Over down on the right, we have got the eye, and then we've got the optic nerve. Remember, we've seen that in the brainstem. And look, the wrapping around here is actually what we can't see because it's hidden by the temporal lobe is the thalamus. Pretty important relay station for sensory information up to the cerebral cortex. So the familiar view is now on the left, and we've got a new one on the right. This is just a different way of illustrating. See, you go from the eyeball crossing down, and here's this thalamus, and then bouncing to the occipital lobe, and it's kind of a feedback system. So here we've got that familiar image, along with two other familiar images to the right, the thalamus and the amygdala, helping you piece together how all this works. So again, all familiar images to you now, the thalamus and the amygdala over on the right, hiding inside the brain. Over on the left, we've got the view of the outer cortex, the dorsal visual stream. Remember, it starts back here in the occipital lobe and moves upward toward the frontal cortex. And then the ventral visual stream runs underneath and may brush up with the limbic system, including the amygdala. So when an image excites you, the amygdala got involved. Back to the schematic. Take a breath. We're going to travel onward and finish this up for you. Okay. We're out of the brain. We're going to just take a look at two studies that compared words to information processing. The first study was done by Lucy Brink herself in 1987. She asked the study subjects to recall a blank, the letter P, a pencil, and a pasture. And then she used multiple ways of recording brain activity. And her purpose was to investigate whether there were different kinds of brain activity associated with just thinking of these different things. And she found that visual, somatosensory, auditory, and motor engagement within the brain were present for all conditions, but in different degrees. So just thinking about different things elicits different activity in the brain. The other study was actually a dissertation, a doctoral dissertation done by Céline Perrier, who is living in Canada. It was her first presentation at ADA in English. She is originally from France, but it was at the 2014 conference in San Antonio. She did a protocol where there was a semi-structured interview, then the subject completed a drawing, free drawing, another semi-structured interview, and then different raters analyzed the interview transcripts as well as the drawing. The drawing analysis was done looking on indicators of functioning according to the ETC components, and then the transcripts were analyzed looking for a relationship between the verbal data and the visual data. What Perrier found was that kinesthetic information processing, as indicated in the artwork, was paired with verbal transcripts that described action, motion, movement, the release of energy. and images that were deemed to be indicative of more sensory information processing were created by people who tend to talk in terms of their internal sensations, their external sensations, noise, texture, temperature, that kind of thing. Ferrier found that people who produced images deemed to be indicative of perceptual information processing used words that focused very externally rather than internally, and they tended to perhaps be stereotypical, conventional, or rigid in their descriptions of things, very factual, matter of fact, whereas people whose artwork was deemed to be indicative of affective information processing tended to use words that were more about their emotional experience, feelings, perhaps even overwhelm and exaggeration. Lastly, she found that people whose artwork was indicative of cognitive information processing tended to have verbal transcripts that reflected problem solving, analysis, synthesis, the ability to abstract, whereas people who had artwork that was deemed to be indicative of symbolic information processing, their words tended to be more about myths, fairy tales, legend, metaphor, dreams, personal meaning and relevance, as well as perhaps a little bit of mystery. So in all, she found that the information processing style that was denoted in the artwork matched the words they used to describe their experience. And on that note, this is something I don't remember if it was Lucebrink or Kagan, who was Graves to me. One of them said in class one day, listen to how somebody talks. You can tell what their native information processing preference is going to be. People who speak in terms of I sense that my mother never liked me, they are physical information processors. They may operate most comfortably on the kinesthetic sensory level. People who would say I feel my mother never liked me, they are probably interpreting the world most readily through their emotional experience. They may be functioning most comfortably on the perceptual affective component. And people who speak in terms of I think or I think my mother never liked me, I believe my mother never liked me, they are probably people who operate on the cognitive symbolic level of information processing. Those are going to be your more intellectual types. And you want to start treatment where people are comfortable. So pay attention. I sense, I feel, I think. That may give you some guidance as to where you need to start treatment. And with that, it's time to wrap things up. So hopefully you've used this presentation to think about your own information processing preferences, because your information processing preferences are not going to be the same as your clients. They shouldn't be imposed upon your clients. Think about my college art. Think about the art you make. What did you learn about yourself and how you can bring this forward into treatment? So this is the ETC schematic presented to you tipped over on its side, because a horizontal format doesn't really make for a great vertical layout of these images unless we want them to be small, which at this point we don't. But now we do. So they're shoved off over on the left to say thank you. I really appreciate your time and attention today. If you have any questions, comments, or concerns, I'm happy to address them. My email address is mvanet@iu.edu, and I wish you a wonderful life of the expressive therapies continuum as you practice art therapy.